Uh, Hi everyone, my name is Cristian Medina, and we're here to talk about practicality beats purity. Um, the main reason for this topic is I've spent several years working in software or computers and in general, and I've noticed a recent trend where folks tend to talk more about technologies or design patterns or tooling or a number of other topics in kind of like a fanatical way where you kind of lose a lot of the logic and everybody's just following this trend of, we're just listening to the previous talk, we were talking about version control where it's like, oh, if you're not using Git, you're doing it wrong. If you're not using Mercurial, you're doing it wrong. Or if you're not a web developer unless you know how to speak React, et cetera, et cetera. So I think that our jobs as engineers involves looking at all of at our solutions and our requirements for building software and our constraints and taking into consideration the guidelines from all of the different design patterns that we are aware of and building something that's custom to our solution. That's the engineering step. So just a little bit of background on why I got to this title also was a Python talk in PyCon last year about dictionary optimizations where the speaker was talking about committing code for all of improving dictionaries all the way up to Python 3.6 and all the arguments he had with the community of floating point purists that were referencing that he was skipping a few things in the spec in order to provide these 20% speed bumps or 50% improvements in memory from using dictionaries. And he says, well, they had their spec, but I have the Zen of Python, which says practicality beats purity. Would you rather I make the practical solution that works for a lot of developers, or should I make a one-off solution that will cripple everybody else, right? So just before we move on a little bit more, I wanted to define my definition of engineering, and this is kind of paraphrased from multiple different sources. For me, it's the application of scientific principles and practical knowledge to invent and build tools and processes which, while you're still satisfying a set of time and resource constraints. The time and resource constraints are key because those things really color how you're going to, which solutions are going to be more important for you and which ones are going to be more relevant. So, what I'm going to do is I'm going to cover a couple of well-known topics or patterns in general that for software and Python, and I'm going to talk about the costs. We are mostly aware of what the benefits are, so it's important to keep in mind if I choose this, then that means I'm giving up this, right? So I'm just going to go over a few of those. Don't take my analysis of the cost of doing these things as I am against these patterns, because some of these are pretty common and very good to use, but it's just something you need to think about when you're implementing new solutions. So we'll talk. First of all, I want to start with modularity and package indexes. This is very important to me because one of the main reasons I came to Python is because it's a language of batteries included, right? Between the internal libraries in the language itself plus the 100,000 plus packaging index community, you can do everything from artificial intelligence to data science to web development, et cetera, et cetera. Now, code modularity and making your code reusable, which is what I really mean in this case, is really important, and it's great to it helps you share code within your teams. And when packaging index came along and are added to all of these different languages, Python is not the only one that does that. You also have the capability of sharing that across other people, right? Especially with open source. So the thing is, when you're writing an application and you're responsible for the function of that entire application, you need to think about which packages are you going to allow into your system, because those packages might have unintended consequences. They might have been written for a particular environment that doesn't really apply in your solution, right? So we'll go over a few things here that are sometimes are gotchas. So let's look at dependency trees. Lately, I've been working with cloud modules, and I have some stuff in Azure that I want to manage, so you do pip install Azure, and this is what you get. 53 packages, right? So yeah, 53 packages, that's maybe good, maybe bad, I don't know, maybe they're simple things. If you look through all of these, some of them look like they're Azure stuff, Azure Management, Azure Common, they're Microsoft packages, probably about all the they decided to modularize it. Okay, that makes sense. But then you start reading some more and you say, well, hey, there's some crypto packages in here. Okay, well, cool. So there's some crypto involved in some of the Azure stuff, but who maintains those packages? I know what they are because I've used them, but if I didn't, I need to go and figure out, especially security stuff, who built them? What happens when there's security problems? Do they get, is there a community around them that keeps them up to date? And then what happens to which one of these packages depends on those packages that brought them in? And what happens to my main Azure package? Do they all rev when I get all of this? And then there's other things like here like CFFI and there's PyC parser in there. These things are just calling REST endpoints. Why do I need that, right? So there's a very famous situation that happened a couple, maybe 3 years ago now. Node.js has their package manager, NPM, and a very, very popular package did some very simple things. I don't even remember what it was, but the maintainer received a cease and desist letter from the corporation, from a corporation that didn't like the naming of the package. And he's like, well, I don't want to deal with the corporate BS behind this, so I'm not even going to rename the package, I'm just going to remove it, right? What happened? Thousands of packages after this did not install because they depended on something that depended on something that depended on something that depended on his package. They didn't even know they depended on his package because they weren't doing checks like this. So then I ask you, you develop an application, you provide it to your customer, you exchange money or something for it, customer calls you and says, I can't install it. What are you going to say? Oh, I'm sorry, it's not my fault, I had a dependency that disappeared on me. You're the engineer, it's on you, you made the choice to put something in that depended on something, depended on something, depended on this thing. So you have to pay attention to what you pull into your applications. Now, I don't have a lot of details on this specifically, but conflicts do happen. Last year, well, late 2016, I believe, there was a bug in the requests package. Everybody used requests for doing HTTP GETs, posts, or whatever. One of them, I think, is the most popular package in Python package index. And I'm using Azure. I'm also using AWS's Bot03 library. Azure's solution, or maybe they hadn't gotten there yet, both of these libraries, as you should, specify the package versions that they depend on, right? It's not just the latest, right? Because you got to be deterministic. Azure was on the version before the bug. Bot03 was on the version after they fixed the bug. So now your installation is non-deterministic because if you install Azure first and then install Bot03, the request packages gets automatically upgraded. If you install Bot03 first and then install Azure, it doesn't get downgraded and you have dependency conflict, doesn't do it. And what happens when you have like a third module that's stuck in there that doesn't, that actually depends on the one that has the bug, right? So you got to pay attention to that. You got to look at your pip install and look at your output from that. Look at the community around libraries and how they maintain things. Now, this is another interesting thing. I like to do my debugging with logging. This is very common practice across different languages, and the Python logging module is pretty good. Some people say it could have some improvements, but I think it's good for what it does. You can do different levels, info, warning, debug, whatever. And so if you're writing a complex application, especially if you're in debug mode, you want to add some dash dash debug to your CLI or something like that to print out more statements. So what happens, all of the modules that you import into application, all of them have the log, or use the logging module. So if I say import bot03, and then you can, and logging, which is how you print the module we're going to use to print to the screen. You can also look at this logger dict, which will show all of the loggers that have been registered, right? So I'm just importing bot03. There's nothing else in there. 36 loggers. Okay? Is this good or bad? Depends on what you're doing. If you don't care about anything below warning, then it doesn't matter. If you care about going into info and you actually want some output of these libraries because you want to know what got sent to the to AWS, maybe you just want to double check that your code actually transformed things correctly for it to get sent correctly, and say you lower this to info, your debug output's gonna exponentially increase. Then that means you have to go back here and add maybe a couple dozen lines of code that say, okay, I want you to disable, bottle core logging. I want you to set that one a warning. I want you to set, bottle core session to debug, but I want you to set, so it gets complicated, and you have to spend the time to actually go through it. But it is important to do it ahead of time because you're not going to get around this. And there's other ways of specifying which logging for system you're going to use or module levels you're going to use for your module. But when you care about some of the things that come back, you're going to have to do this at some point in time, and you don't want to be surprised when you run into a big problem and you have to go do the debug and make your logging meaningless. When you make the log so long that you can't parse through what's going on, then you start losing confidence, and it gets really complicated to try and figure out how to handle things. So the other thing is call stacks. So I'll give you a slightly exaggerated example. I very recently was using a very popular REST framework, right, to provide an endpoint function to get me some JSON out of something. That framework then tied to a very popular serializer and deserializer. But before I used any of that, there was a different framework that helped me do input validation and getting into the endpoint function, right? There are 3 frameworks. The key here is framework. Frameworks are great. They help you abstract things. In order for them to abstract things, they need to write more generic code. They write more generic code, that means there's usually more classes or more function calls in between all of them. So I found myself in a situation where some output of my endpoint function, which was simple dictionary that I could just serialize to JSON very easily, was running into some problem. And I had a 20 deep, almost stack trace of what was going on. And if you don't own the code of any of that, trying to figure out how to, what tweak you need to do to your output to get it into the other framework so that the other one does its magic, because I call it magic, winds up being magic at the end, to it so that at the end you get the little output that you wanted. Is it worth it? Is it worth your time to actually do that? In some cases, yeah. In some cases, no. In my case, I threw out 2 of the frameworks, rewrote what they were doing for me myself. Took me a couple days. And reduced my call stack from 20 to 5 and improved my response time by 200 milliseconds. So things to keep in mind, right? So just to summarize, this is kind of what we talked about on modularity and package indexes. One more, so just to go on to another topic, SQL versus object relational mappers. So I have done a lot of SQL optimization over the years, and it's, I don't know if it's a control thing, but I like to know exactly what it is that I'm asking my database. Databases are optimized for retrieving data and for filtering through that data, right? Object relational mappers help you massage that data into language constructs so that then you can reuse it in your language. And that's a very valuable thing, depending on what you're doing, right? And so you need to be aware that that massaging has a cost. And if you have a really complicated system with a lot of relationships, with a lot of joins in your queries, you can wind up in a situation where you need to, instead of learning SQL, you need to learn to speak ORM, right? Oh, the generic, I made this a little bit generic, so it's kind of hard to tell, right? But, I have a class, but I only wanted these attributes out of it, but this wasn't enough. Somehow I had to specify that I did not want to load this separate attribute or this separate attribute of this object in the hierarchy, but I do want to join load with all of this. If I look at this, I can't, like, just off the top of my head, I've been doing this for a while, tell you that what the SQL that comes out of this. The worst problem is you gotta learn how to specify all this stuff in your ORM, and then you gotta learn a little bit of SQL so that you know how to get the optimized SQL that you want out of it. Because if you don't do this right, this could be an order of magnitude difference in response times, because you can get, when you define your classes in an ORM, you can say, if this object, when I load this object, I want you to proactively get this information for me, because in most cases I want this information proactively. But maybe some of it is lazy loaded, right? If I do a lazy load, that means if I have a query with 1,000 things in it, for every line item that it doesn't have the attribute that I need, it has to go do another query. So then I have to worry about dozens of queries to my database versus one gigantic query that I can do ahead of time, and the database knows how to optimize. So again, this is one of the drawbacks of ORMs. And SQL Alchemy, which is the most common one used in Python, is pretty good. There's another one called PyORM, which is also pretty good. You just gotta go dig through the documentation to figure all of this stuff out. And sometimes that's not easy. So the other problem I have had, is scaling with ORMs. So let's say you have a user object and you have a teams object. A team can have multiple users, right? So when you have an ORM and you're trying to get a list of users, you ask the ORM translates to some SQL, it asks, say, the MySQL or Postgres module you have in the back end to actually go query the database. The database gets the command, does the stuff, gives it back to your MySQL or Postgres module, which then returns it back to your ORM. And then for every single one of those returns, and say you want to put this out into a REST API, right? So let's say you want JSON out of this. For every single one of those returns, which came back in a tuple, usually, you're going to iterate and instantiate a new class of your user. And for every user, you're going to instantiate a new class of your team. At the end of all that, what did you do all that instantiation for? Just so that you can iterate through all of it and go into the properties, which is a function call, and get all of the properties, stick them into a dictionary, which then you're going to serialize into a gigantic string. So how many copies of the data? I mean, it's probably 3. It might be less than 3. Python does a lot of optimizations for you. So I've written endpoints where, at design time, this was acceptable because we were only going to get like a couple dozen things out of it. But then it grows to, 1,000 entries. That's not a problem for a normal database, but it's a problem when you start getting an ORM into it. I've written applications with tables that have millions of lines in them, and it's perfectly acceptable to query those tables and get the information out of it quickly, right? You need to pay attention. You can turn this off in ORMs too. You just need to figure out how you do it and what's more convenient for you. Right, so that's SQL and ORM. So I'm going to talk a little bit about microservices and versus monolithic applications. I don't have any examples, so I'm just going to go over like a few of the issues. So is anybody not aware of what a microservice is? You want a little bit? So microservices in general means You take a large application and you modularize its components and separate it out into individual separate applications. So if I have something that has, say, a user management portion, I can take the user management portion out, stick it into a separate repo, and maintain that code separately, and anybody else that's using the same type of user management can reuse that code. On top of that, you get a couple of interesting things because microservices involves, they're so small that you run multiple instances of them to handle load. And you get load balancing, you get availability, you get, because of that, you can easily restart them and get a new one because they're kind of self-contained, and some reliability because of it. All of that comes at a cost, right? So what you're doing when you do this is you're exchanging one set of problems for another. You're changing complexity of software or of your core services, right? You're making it simple. You don't have to worry about all the function calls between everything, but you do have to worry about the infrastructure that maintains all of these microservices and keeps them running for you. So what does that mean? Well, which one of them are online? What is the status? What are their IP addresses? How do, that changes over time as well, and in order to keep them up to date, and to keep the availability, you usually have them behind load balancers, so that means extra latency. So an example of that is you make a request to your application that usually goes to, say, directly to your application, goes and grabs some information for a user for you. Well, now you split off user management, so you make your request for your application. That means you're modularized in this way, so that goes to a load balancer that determines which instance of the application is going to run it. You go into that endpoint. The endpoint realizes, oh, this is a user query. The user stuff is actually over in this URL over here. That also has a load balancer in front of it. Then you get to the actual instance of the user stuff, which then actually queries the database, gets the data back, sends it all the way to the wire, you massage it, and send it all the way back. So you're serializing out of the database, deserializing, massaging it, and reserializing it again back to the user. So all that costs time, but usually this trade-off is, if you're aware of what you're doing, is good. I mean, it's good enough, right? Then you run into some interesting complexities with logging and debugging. So first problem, different microservices running in, say, different virtual machines, different instances of the same code, they're not going to have the same timestamps. There is a computer architecture, a processor architecture, and the way virtualization works. Issue, it's not really an issue, it's just the way it works. Things are not going to be very accurate timestamp-wise, even if you're running on the same physical hardware between all your virtual machines. So then you have to come up with a way of synchronizing things, either with some common RTC clock or whatever, an NTP protocol. But even then, if you don't do that often enough, you're going to have some drift in between. So if you're receiving logs and you're trying to compare across all your services, I came here, then I came over here, and did this line up? Was this created by this request? That gets pretty complicated. So one of the main solutions for that is to have a central logging server. You usually, things like Docker or, Docker specifically helps you change your standard out into UDP packets that you can send to a central server, and in the server you just go chronological and see how they come in. But there's still UDP packets, so you're not necessarily getting them in chronological order, but it helps a lot more because it's all in the one place as they came in. So you have to worry about that, which is also a central point of failure, but it can also produce help you with debugging and produce some extra alerting mechanisms and things like that to help you with it. There's actually an entire software systems built for this stuff. There's like a whole business. So let's see. So I'm just gonna leave it there and open it for questions. My last point for you guys is software development is about exchanging one set of problems for another. You got to be aware of what you're giving up and aware of what's the real world value. This is important. real world value of what you're gaining. I say this because a lot of people will try to convince you of value, but that value is different between people depending on the environments and the software that they're developing and for what purposes. All right? So for you, what does it mean to use microservices versus monolith? For you, what does it mean to have 98% test completion because that's what some test methodology tells you, right? Any questions? Mm-hmm. I don't remember the name. I'm sure if you like Google around, you'll find it. There were a bunch of news articles on it. It broke a lot of stuff, and then somebody had to like pulled out an old version or whatever, and then put it back up, and in order to solve it. It was very interesting. Yeah, yeah, yeah. Right, it was a padding thing. Yeah, it was just like a very simple, in the grand scheme of things, thing, but everybody depended on it. Yeah. Yep. All right. Anybody else? Cool. Well, thanks, and thanks for coming to PyCaribbean, and have fun.